Hi guys, so by request we're gonna go ahead solve more logarithmic equations. So before we do, gentle reminder, so a logarithm, what is that? A logarithm is pretty much code for an exponent. So again, if you remember that a log is just an exponent, then you're good. A few housekeeping rules. The base has to be a positive number with the exception of 1, and the argument also has to be positive. And again, it's not because the book said so. It's just for math. Any positive number raised to any power, whether positive or negative exponent, is always going to yield a positive number. All right, cool. So let's go ahead and start problem A. So when it comes to solving logarithmic equations, what I need to ask myself is this: how many logs do I have? One log or more than one log? So as you can see, we have more than one log. So if we have more than one log, then I need to fix it so we have no more than one log on each side. And this problem is kind of funny because yes, we do have no more than one log on each side, but what I want to point out is that we don't have two logs set equal to each other. So at this point, we cannot apply the property of logarithmic equations. Let's go ahead and move one of these logs to one side. I'm just going to go ahead and move the one on the left. Undoing of addition is subtraction, so let's go ahead subtract log of x minus 2 from both sides. Oops, sorry, x minus 2. Sorry, my hand is in the way. And when we do that, we'll leave you with log of 2x plus 1 minus log of x minus 2 is equal to 1. So again, I'm going to go ahead and ask myself the same question: how many logs do I have? One log or more than one log? And we still, have more than one log. But then the next step is I need to fix it so we have no more than one log on each side. And let's go ahead and do this. So then the question is, how am I going to backtrack it to get to a single log? So that's where I'm going to vent out my frustration. So I'm like, silly logarithm rules, they make me so mad. But we're just going to throw an S at the end. So silly logarithm rules, they make me so mad. So what I need to ask myself, what's going on? Am I adding the logs? Am I subtracting the logs? And as you can see, because we're subtracting the logs, then when we backtrack to a single logarithm, we're going to go ahead and divide the argument. So we can say take their quotient. So that will give us log. And then we're going to divide the argument. So the first argument divided by the second argument. Cool. So I'm exhausted. So let me remind myself, okay, how am I going to handle it? Now that we only have one log, then we want to go ahead and write it into exponential form. So you can either remember, log base b of x equals y means b to the y equals x. If that works for you, cool. It doesn't really work for me because it's hard for me to remember formulas, but I rather put it into words. So I remember that to go from logarithmic form to exponential form, or in English, to get out of the log, I'm going to take the base, raise it to some power, and that should give us the argument. So, I mean, you remember it however you want. It's a personal choice. For me, it's easier to do it in words. If for you, it's easier to put it in formula. Means b to the y equals x, or whatever nice memory you have. Go for it. Okay, so the base is not highlighted, which means we have the common logarithm, which is a special name given to a logarithm of base 10. So we have base to some power equals argument. So the base of the logarithm is 10. And again, remember we had said that the log is just an exponent. So if the log equals 1, then the exponent equals 1. So base to some power give us the argument. So now we no longer have a logarithmic equation. In this case, we have a rational equation. So bear in mind, when we have a rational equation, we also need to watch out for restrictions on the variable, or domain. What makes the denominator equal to 0? If you want to know what makes the denominator equal to 0, you're going to take the denominator and set that equal to 0. So we want to tell the world, x could be anything with the exception of 2. I was going to say something else. So at this point, you go ahead, solve this however you like. For me, it's to undo the division by x minus 2. Let's go ahead, multiply both sides by x minus 2. So So we multiply the left side, we multiply the right side. Take your time, you know, work with each other. Pause this video, rewind it, do what you gotta do. We'll distribute the 10. That will give us 10x minus 20 equals quotient of x minus 2 in itself will give us 1, and that will give us 2x plus 1. So we went from a logarithmic equation to a rational equation to a linear equation. So if I can read your mind, let's go ahead, subtract 2x from both sides. That way we can have the variable terms on one side only. When we do, that will give us 8x minus 20 is equal to 1. For the almost grand finale, to isolate the variable term, let's go ahead and add 20 to both sides. And that will give us 8x is equal to 21. You take your time, we freehand it, or you use your calculator to write the decimal equivalent. I'm going to keep it in fraction form with your permission. So now, I think we nailed it because I know you guys would have stopped me if I made an arithmetic mistake. But in this case, I need to make sure that that my solution doesn't make any of the arguments negative. So I'm going to do what I call the argument check. So you don't have to write it, just can I project my work? I really can't. Okay, so I'm just going to write down the arguments then because I can't project the original equation. So we have argument check. So sometimes we just eyeball it, sometimes we actually crunch it in. It just depends on the mood that I'm in. So 2 times x, or 2 times 21/8 gives us some nice number. And for the argument check, I just want to make sure is my argument positive, because that's one of our properties of our logarithms. The argument has to be positive. I'm not really good at arithmetic, but I think that 2 times 21/8 is some positive number, and you add one more is some positive number. So we're just going to say that our argument is positive, so we're good. But I believe we had one more argument involving a variable, so let me go ahead, highlight it. Where am I? The argument was, there I am, x minus 2. And I want to know, does my solution pass the argument check? Meaning I got to make sure that my argument is positive. This one is a little bit harder for me to eyeball, so I am going to show some work. When we write the equivalent fractions, we have that 2 is the same as 16/8, and that will give us 5/8, and that is a positive number. So the argument check, it's not that we're checking to see if it's a solution. We just want to know if it flies, and in this case it does. For those of you that are overachievers, then you check it. You know how to check it. You know, substitute your answer for the variable and then make sure the left side equals the right side. But we don't have time for that. So let's go ahead. I'll move on to problem B. Okay, so problem B, again, another logarithmic equation. So again, when it comes to solving logarithmic equations, what I need to ask myself is this: how many logs do I have, one or more than one? And as you can see, we have more than one log. And if we have more than one log, then we need to fix it so we have no more than one log on each side. So again, this is another sneaky problem because we do not have more than one log on each side. But the thing is, we don't have two logs set equal to each other, so at this point we cannot apply the property of logarithmic equation. So let's go ahead and move one of these logs. With your permission, I'm gonna move the one on the left. Opposite of subtraction is addition, so let's go ahead and add log of x minus 2 to both sides. And when we do that, will leave us with 1 is equal to log of 3x plus 1 plus log of x minus 2. Fantastic. So now at this point, we're going to go ahead and use the properties of logarithms to backtrack to a single log. So again, it's a little bit hard for me to remember the product, quotient, and power rules of logarithms, so I just vent out for my frustrations, because when I forget, I get mad. But when I get really upset, I get mad. So I'm going to ask myself, do I have an addition problem? Do I have a subtraction problem? In this case, we have an addition problem, or we have a sum of logs. And whenever we have a sum of logs, we're going to backtrack to a single log by multiplying the argument. So that will give us log. Base is not highlighted, which means we have the common logarithm, or base 10. Again, we're multiplying the arguments. So we have 3x plus 1 times x minus 2, and with your permission, we're going to go ahead and put a bracket for my peace of mind, just so I can highlight to myself that the actual product, the entire product, is the argument, equals 1. Okay, So you do what you gotta do. You can simplify the argument, but I'm gonna take a pause right here. So the question is, okay, well, how are we gonna solve it? Well, now that we only have one log, let's go ahead and put it into exponential form. So remember, to get out of the log or to put it into exponential form, we're gonna have base to some power equals argument. Cool. So the base of the logarithm is not highlighted. Let me go ahead and highlight that for us. So the base is 10. The power, I really don't see it, so I just have to remember what's so special about a log. Oh, a log is just an exponent. So if the log equals 1, then the exponent equals 1. So we have base to some power equals argument, which is the product right here. So we're going to take our time and then multiply the binomial. So product of the first terms will give us 3x squared. Product of the outer terms gives us negative 6x. Product of the inner term is x. Product of the last terms is negative 2. And that equals the left side. It will be nice if I bring down the other side of the equation. When we combine the like terms, that will give us 3x squared minus 5x minus 2. And then at this point, I'm going to ask myself, what kind of equation do I have? Same speech, linear, quadratic, rational, radical, logarithmic, exponential. In this case, we have a degree 2 equation or quadratic equation. So you can solve by factoring, quadratic formula, completing the square. For me, I like factoring, so I'm going to assume it's factorable until I realize it's not. So if we're going to solve by factoring, let's go ahead and set the equation equal to 0. Now for me, factoring is not my forte, so I don't really like to do guess and check because I'm not a good guesser. I'm going to go ahead and use the AC method. So a gentle reminder, the gist of the AC method is to split the middle term so we can have 4 terms and then factor by grouping. So we're going to go ahead and do the x game. So the x game, we want to find factors of A, C that add up to B. So factors of A and C, leading coefficient is 3. So that's A, constant term is negative 12. So that's our C. So we want factors of AC that add up to B. So product of 3 and negative 12, I believe, is negative 36. Value of B is negative 5. So we want factors of negative 36 that add up to negative 5. I know there's a 9 and a 4 involved. And in this case, because the sum is negative, then we need the larger factor to be negative. So I'm not a risk taker. Let's go ahead, check it. Product is negative 36, sum is negative 5, we're good. So now when we split the middle term, we're going to use the signs in the x game as the coefficients of the middle term when split. The variable part of the middle term is x, so when we split it, we will replace it with negative 9x and positive 4x. So that will give us 3x squared. The sides are negative 9x plus 4x minus 12. So remember, when we split the middle term, we're not like changing our expression because negative 9x and 4x plus 4x still gives us negative 5x. So let's go ahead, continue, and we factor by grouping. From the first group, if we take our time, we could factor out a 3x, and that will leave us with x minus 3. From the second group, we take our time, we'll factor out a 4. And that will leave us with x minus 3. So as expected, because we had checked our x game, the binomial factors match. So we're going to go ahead factor it from the expression. And when we do, first product over common factor, the binomials cancel out. And that will leave us with 3x. Second product over common factor, the binomials cancel out. And that will leave us with 4. Cool, fantastic. So at this point, I mean, you do what you gotta do. You can do it mentally, or you can show work. It's a personal choice. So product equals 0, so one of these factors has to equal 0. Either the first factor equals 0 or the second factor equals 0. If the first factor equals 0, that's gonna give us 3. And if the second factor equals 0, after we subtract 4 from both sides and then divide by 3, that will give us that x equals negative 4/3. And again, I know we nailed the algebra. I know we did. I don't think we did an arithmetic mistake. But I just want to know, my answer is actually acceptable. Okay, so I want to know, do my answers pass the, excuse me, So I need to know, do my answers pass the argument check? Sorry about that. I had to take a little break. So where was I? Yes. So I know we nailed the algebra, but the question is, are our answers acceptable or are they reasonable? Do they pass the argument check? Meaning I have to make sure that arguments are positive. Most of the time I don't really write down the argument check, but in this case I cannot project the original problem, including the proposed solution. So with your permission, let me go ahead, highlight the arguments, and I want to make sure are the arguments positive after we plug them in. Okay, so for the first proposed solution, the argument check, let me just put argument check. We have, where am I? Give me a sec. Technical difficulties right here. Okay, so the argument check, we have x minus 2 and our proposed solution is 3. And when we substitute a 3 for x, that gives us 1. It is positive, so we're good. Let me go ahead, plug it into the next argument involving a variable, which was, if you can look at your paper, it was 3x plus 1. And I'm not good at math, but 3 times 3 is positive, plus 1 is positive. So I'm just going to put positive and be on my merry way. So I know that 3 is a solution, but just because 3 is a solution, it doesn't mean that negative 4/3 is. So let's go see if negative 4/3 also passes the argument check with flying colors. So the first argument involving a variable is x minus 2. And I want to know, does negative 4/3 pass the argument check? And the answer is no. Negative number minus more negative number gives us a negative number, and that makes me pretty sad. Okay, so it doesn't pass the argument check. Now the question is, wait, should we check it against the other argument? No, once it doesn't pass the argument check for any of the arguments, then it's not going to be a solution. So we had two possible answers. One couldn't fly. We still have one answer to go by, so we have a solution, namely 3. So I know that you guys are tired, but I did promise you 3 problems, so don't worry, you guys, you can pull through this. Okay, so problem C, we have a, let me see if I wrote it correctly. Sorry about that. I think I did. No, I did not. Oh, I'm glad I caught this. Okay, so this is log of 6x plus 5 minus log 3 equals log 2 minus log x. Totally defeated the purpose of me pre-writing it. I think I wrote it now correctly. Okay, so let's do this. So the same question of the hour, how many logs do I have? 1 or more than 1? And as you can see, we have more than 1. So if we have more than 1 logarithm, then we need to fix it so we have no more than 1 log on each side. And we're going to use the power, quotient, or product rules. So I'm like, what are those? Oh, I'm so upset. But upset doesn't really work for me. So, what are those rules? I'm so mad. And I'm so mad that I'm going to say I'm so mad. I'm like, silly logarithm rules, they make me so mad. So we're going to look at the left side and see if we have an addition problem or a subtraction problem. As you can see, we have a subtraction problem. So in order to backtrack to a single logarithm, we're going to go ahead divide the arguments. So that's going to give us log of the first argument divided by the second argument equals, on the right side, we're also subtracting 2 logs. So when we backtrack to a single logarithm, we're going to divide their arguments. So it'll be log of 2 over x. Log of 2 over x. And at this point, I'm going to ask myself, well, how am I going to handle it? So I want to point out the difference between C and problem A and B is that in C, we have one logarithm with same base equals another logarithm with same base. So let me go ahead, highlight the bases. I know you know it's 10, but for me, if I don't see it, then I have a problem. Okay, so then at this point, we are going to go ahead apply the property of logarithmic equations, which reads, sorry about the stuttering. So the property of logarithmic equations reads, if the bases are equal, then there's no way around it. The arguments have to be equal. So let's go ahead equate the arguments to each other. So left argument equals the right argument. And once again, we have another rational equation. So in this case, x can't equal 0. And then you can solve it however we like. We can go the LCD route, multiplying both sides by 3x, or we can just go the proportion route for this particular problem. I like proportion, so let's go that. Let's go in that direction. So if we go the proportion route, we're gonna go ahead, take the cross products and set them equal to each other. So the first cross product will give us 6x plus 5 times x. So let me go ahead, put the x on the other side. That should equal the other cross product, which is given by 2 times 3, or 6. So let's go ahead, take our time, simplify the left side. We clear those grouping symbols and we take it from there. When we distribute the x, that will give us 6x squared plus 5x is equal to 6. So this is a degree 2 equation, so we are going to solve it by however you want. You know, for me, I love factoring if possible, and if it's not factorable, then we use another technique. So let's go ahead, set this equal to 0, assume it's factorable, and if it isn't, then just kidding, we'll use another technique right there and then. Okay, so when we set this equal to 0, that will give us 6x squared plus 5x minus 6 equals 0. And if you love factoring, go ahead, solve it factor however you want. Some popular methods, aside from trial and error, guess and check, is box method, smiley face method, asterisk method, bottoms up method. I'm gonna tell you a secret. It's all the same method. There's only 2 methods: guess and check and AC method. Any other method is just AC method in disguise. Trust me. All right. So let's go ahead, factor by using the AC method. So we're going to go ahead, set up the corresponding xk. So we want factors of AC that add up to b. So let me go ahead, highlight my ABC. So product of A and C, namely 6 and negative 6, will give us negative 36. Value of b is 5. We take our time. Factors of negative 36 that add up to 5. I know there's a 9, there's a 4. The sum is positive, so the larger factor needs to be positive. So let me check it, because if this x game is wrong, then this is never going to happen. So product is negative 36, sum is 5. We're good. So let's go ahead, split the middle term using the size of the x game as a coefficient of the middle term when split. So that will give us 6x squared. 9 is positive, so plus 9x minus 4x minus 6 equals 0. Now that we have 4 terms, let's go ahead, factor by grouping. From the first group, we can factor out a 3x, and that will leave us with 2x plus 3. From the second group, I know that you know that 4x and 6 have a common factor of 2, but what I like to tell my students is this: it doesn't matter what you're trying to do. When it comes to taking out common factors, always fix it so the first term is positive. So in order for us to do that for this exercise, let's go ahead, factor out a negative 2. Okay, I think I made the arrow a little bit too long. Sorry about that. So if we factor out a negative 2, that will leave us with 2x plus 3. And because we made sure that our x game is correct, it's no surprise that the binomial factors match. So let's go ahead, reward ourselves by continuing the factoring process. So we take our time. When we factor out the GCF, or the binomial factor of 2x plus 3, first product over common factor, the binomials cancel out. That will leave you with 3x. Second product over common factor, the binomials cancel out, and that will leave you with negative 2. And it's up to you how much work or how little work you want to show, but I love showing all my work, because when I don't show my work, I tend to make silly mistakes. Okay, so product equals 0. Let's go ahead, apply the 0 factor property, and then set each factor equal to 0. So if the first factor equals 0, when we subtract 3 from both sides, that will leave us with 2x equals negative 3. And after we divide both sides by 2, that will give us x equals negative 3 halves. For the second equation, after we add 2 to both sides, that will give us 3x equals 2. And we take our time. After we divide both sides by 3, that will give us x equals 2/3. Alright, so we know we nailed it, but the question is, do these answers fly? Do they pass the argument check? I'm going to go ahead and write the original equation over. Okay, so we have log of 6x plus 5 minus log of 3 equals log of 2 minus log of x. The reason why I wrote it over is because I want to highlight that when you do the argument check, you don't have to necessarily write it on paper. I mean, you can, so you can have a paper trail. But let me go ahead and check our first proposed solution. X equals negative 3/2. I'm going to purposely skip the first argument. I'm going to go to the second one involving a variable because it's easier for me to check. Okay, so let me highlight the arguments involving a variable. So when we do the argument check, we want to make sure that our arguments are positive when we substitute our answer into the equation. If x equals negative 3/2, negative 3/2 is not positive, so this doesn't pass the argument check. Alright, now let's check 2/3. Let's see if it passes the argument check. If x is 2/3, 2/3 is positive, so we're good. If x equals 2/3, 6 times 2/3 is some positive number. You add 5, we're still positive. So 2/3 passes the argument check with flying colors. Alright guys, so I promised you 3 problems. I think this was our longest video yet, but it's okay. Thank you guys.